Okay, so yes, this is going to pick up most of the talking, so I can send it to your parents and stuff.
That's what I was thinking.
All right, Stephen is creating a model of the Washington Monument for history class. The model will be 1/100th of the monument's actual size. The square pyramid, and if we talk about square pyramids, we're talking about a base that's a square, and then has triangles that all come together leaning in at one point, in one vertex. The square pyramid sits atop the monument's obelisk shape, has a slant height of about 57.6 feet. Each side of the pyramid's base is about 34 feet. Now we're not, well, I can zero in a little bit on this. So we're talking about that peak point right there. And the dimensions of that, they're giving me are 34, no, not going to let me write on it. Is 34 feet is this base, and then the slant height is 57.6. That's the height there. Okay. So what would the area of one of the triangular faces of the actual pyramid be? How would we find the area of one of those triangles? What's the formula for area of a triangle, Savannah? Base times height divided by 2. Okay, so those two lengths that were given are the base and the height of the triangle. So we're going to go, everybody get your calculators out. We're going to be doing a lot of calculating, so have those available so we'll make sure to do this right. I need you to take 56.6 times 34 for me, please. $1,921.
Yeah.
Point what?
Oh, maybe I did that wrong.
It's 1,924.
So sorry. I typed in the wrong number.
4 point what?
What?
Is there a decimal?
Yeah, 4.
And this is in feet squared. That would be the area of the actual Washington Monument peak. Okay. Now, what's the next question say here? What is the slant height of the pyramid on the model going to be? So we know that the slant height of the original is right here, 57.6. The model is going to be 1/100th of that. So how would we find what the model length should be?
Divided by 100.
Multiplied by what? What did you say, Alex?
Are we taking 57.6 times 34 or 56.6?
57.6 times 34 on this one.
1,958.
We'll get that one. Okay. Alex, what did you say?
I typed it wrong. Okay, good.
We're on the next one, Hannah.
Hey,
We
is it
moved on.
squared or cubed?
It's squared because it's area.
If you're trying to figure it out, it's not nice like
Ah, say that louder though. That's what I thought you said.
Yeah, like you divide it by 100.
Okay, taking the slant height, the actual slant height of 57.6, we're going to multiply it by 1/100th. Multiplying by 1/100th is the same thing as dividing by 100. Just like the multiplying by 1/2 is the same thing as dividing by 2. So dividing by 100, how do we divide or mentally divide a decimal number by a power of 10?
You just do it the easier way and divide by 4 times it.
Yes, we're going to divide by 100, but what's the easy way to do the math on that? Tuck?
Move the decimal. I don't know.
Yes, say it, continue. You're fine.
Okay.
Move.
The decimal over how many zeros there are.
Yeah, move the decimal over the number of zeros. So we're going to take 57.6 and we'd move the decimal over 2 places to the left, would give us the value of our model height, slant height. Moved it over 2 decimal places. So on the, if that's the case with our slant height, what would we do to our length, our base length of 34 feet if we wanted to find the model length for it? Divide it by 100 again. Okay, multiply by 1 over 100 or divide it by 100. If we divide 34 by 100, the decimal moves 2 places to the left, making this a value of 0.34. Okay, so that's your slant height and your base length. How would we, Olivia, find the area then of the model triangle? How do we find the area of a triangle? On a triangle, we don't have circle part. Base times height divided by 2. Area of a triangle. Base times height divided by 2. Difference is our base and our height are now 0.576 instead of 57.6 and 0.34 instead of 34. Since we moved our decimal over 2 places on each of those, is our answer going to be just moving the decimal over 2 places on our answer? Hannah says yes. No. Plug it in and see. Well, I cleaned my room of the debris. How many of you have calculated that? 2 people have calculated that. Put it in your calculators. 0.576 times 0.34.
0.19584. Wait a minute.
So it's 0.19584.
Yeah.
On our length of our slant height of the model, we moved our value over 2 places to get the decimal in the correct spot by dividing it by 100. Then we did the same thing on our 34. We moved our decimal place over 2 places. But then we multiplied those 2 values together, and the decimal had to be moved from here in front, which is a total of how many places? 4 places. So when we take a number, we've moved the decimal over 2 places, take another number, moved it over 2 places, that's a total of 4 decimal places. So the product of that would have to be changed by moving the decimal over 4 places. So the ratio of the monument to the real thing or the model as the scale factor was 1 over 100. That's just the basic length difference was 1 to 100. 1 inch on the model is 100 inches on the real thing. But when it came to the area we had 1 over, we moved it 4 places. What's the relationship between 100 and 10,000? Anybody know what? Did I say 10 and 1,000? What's the relationship between 100 and 10,000? Huh? What's 100 times 100?
1,000.
Try again. 10,000. Is there a relationship between 100 and 10,000 then?
Yes, there are places of 10 or something like that.
Okay, powers of 10. If I took and squared 100, 1 over 100 squared would be the same thing as 1 over 10,000. So when we converted area in the past, we had the problem with the house and the porch on the front and the back, and then we had the garden and all that kind of stuff. If we had an area given to us, say this is 30 inches squared, if I were to want to enlarge that by 4 times, I took 30 times the scale factor of 4, but I had to square it. Okay, making that 30 times 16 instead, so we give that to be 420 inches squared.
Wait a minute. Wait, what? Wait.
I'm waiting.
Okay, all you do is put a 0 at the end.
I didn't, that's not right.
No, it's not.
Yeah, 16 times 3 is 42, isn't it? No, it's not.
30 times 60.
48. Oopsie. There we go. I just forgot to write the rest of my 2. Okay, my 8.
That is 3. That is 4.
Okay, we did this part in the past. When you multiplied to multiply by a scale factor on a model situation, or if we're getting bigger or smaller, we squared whatever that scale factor was. Okay, that's what we did right there. I wanted to take it for. If I wanted to reduce it by 1/2, then I would have taken 30 times 1/2 squared, which would be 1/4. 30 times 1/4, and then that would be 7.5, I think. 7.5. If I were to reduce it by half. Okay? So that was area. Today we're going to work with surface area, doing the same type of thing, but we're also going to deal with finding the volume of similar solids. Similar solids are solids that are shaped the same, they're just a different size. Just like a similar figure. So any cube would be similar, because all the sides are the same length, it's all proportional, all that kind of good stuff is taking place. The surface area, we're given the surface area of a rectangular solid. So we have our prism. So we know we've got this figure that's shaped something like this, maybe. And we know that as the surface area of it is 78 centimeters squared. We want to find out what the dimensions that would be 3 times as great as that. What would the surface area be of an image that has 3 times that surface area? Well, in order to, or if we were to multiply by 3 times, we'd have to take our 78. We're still dealing with area, aren't we? So we need to take our 78 times what? What's our scale factor? First of all. It will be. What's our scale factor though?
3 squared.
3. And we're going to then square that. Our scale factor is given to us as 3 times as great. So times 3, but we have to square it because we're looking for the area. And that's 78 times 9.
Which is 702.
702 centimeters squared. Fourth hour today, I didn't read the directions very closely like many of you didn't on your homework assignment. And I assumed that it was talking about volume. So I messed that one up. Okay, so if we had 34 square inches on a triangular prism for the surface area, and I wanted to find 3 times that, I'd take times 3 squared. Even if I have a fraction, that's okay. 352 times 1 over 48, and just I'd have to square that. So I'd take 48 squared and divide 1 by that value to get the decimal value to multiply by. We're not going to do that on these two. We're just going to move on, but I want to show you that. Now, when it comes to volume of a converting volume by a scale factor or changing volume by a scale factor, it's very similar here. We have a triangular prism that has a volume given to us of 432 cubic yards. And we want to reduce that by 1/3. So we're going to take our 432 times our 1/3, but we're dealing with volume. And we have to measure volume in cubic dimension, right? So we have to cube our scale factor. Now 432 times 1/3 cubed would actually be 1/27. 1 times 1 times 1 on top is 1. 3 times 3 times 3 on bottom, 27. Is 432 divided evenly by 27, folks? Calculator people. Who just said what?
Yes, 16.
16. And we would still be in yards cubed. You're just taking and multiplying by the scale factor, cubing it if it's volume, squaring it if it's area. This one was a pretty interesting one. Took us a little while to do it. Okay, so you have this picture to the left of this problem, where the hockey puck is inside the building. It looks like it's going through the building. Somebody smacked it into there. Yeah. Sorry. Ugh. Well, this puck here is an example. It shows the dimensions of an actual hockey puck. This one that's in the wall is 40 times this one. Okay. This wants us to find, the problem wants us to find the volume and the surface area of the giant puck. So let's start with the surface area. The formula again for surface area of a cylinder, we've talked about this, is pi r squared h plus two pi r squared. The area of the circle times the height, and then 2 times the area of the circle. I didn't do that right. Surface area, not volume. Surface area is pi d. Pi d, pi r squared. Where we take the circumference of the circle, what would the circumference be? My radius is 1.5, so what's the diameter going to be? If the radius is 1.5, you have to double that to get to the diameter.
1 plus 1 is
2.
and then 5 plus 0.5 plus 0.5 is
And then another one, total of 3. Great, okay. So we're supposed to use 3.14 times 3. I would, in your calculator, put a parenthesis, then 3.14 times 3, and then the height of our puck is 1. I put that in parentheses,
9.5
and then put a plus sign,
plus.
and then another parenthesis, because we're going to take 2 times 3.14 times 1.5 squared.
Wait, what now? Does that say 23.5 or 2.3?
2 times 3.14.
23.55.
So 23.6 if we round to 1 decimal place
Yeah.
would be the surface area. You have that in your calculators?
23.5. Yeah.
No.
I do my.
Alright, I'm going to hope that that's right. We'll go with Haley on this.
I got the same answers.
Good.
Well, you're on.
Now we are trying to get to the actual big one, the big puck surface area. So we're going to take this times, what's our scale factor?
40.
40.
You were way off, Haley. That was the last one.
We're dealing with the area, so we're going to
Times it by multiply.
multiply it by what?
The 40
40.
cube. Square.
We're dealing with the area.
Dose.
So it's squared.
That's 37,680.
And it's in inches
Cube.
squared because we're still in area.
You know what I meant. Did you guys
3,678. What'd you get, Gabby? 37,000.
That's what I said. Yeah, that's what I said. That's what we said.
I'm sorry.
It's okay.
Thanks.
We all make mistakes.
37,000.
Especially you. 760.
It's because they repeated it.
It's because I can't. I'm kind of like Dora when it comes to repeating.
Say Dora.
Dory, sorry. Dory.
I said Dora.
I'm definitely not like Dora.
She's still.
37,760. I'm not like
That's not what the book says. That's where they got it from.
Mm-hmm. This is my last change on this, so whether or not it is.
Oh yeah, I know why. It's because the book took 23.55 and we took 20.
So it's just a little bit off.
I don't think I found it.
What'd you use?
Had to get a pencil.
Lost your earrings.
Okay, what's the next part of the problem?
Volume.
Volume of it. This is the easier one. I saved the easier one for later. Volume of a cylinder. This is pi r squared h. So in your calculator, you take 3.14 times 1.5. Gee whiz. 1.5 squared times the height of 1.
7.065.
0. Point.
It's 7.065. That's what I said.
I just couldn't remember. I told you I'm not able to. Okay, and that is in inches squared, or sorry, inches cubed. So how would I find the volume of the big puck that's inside the building there, stuck in the side of it?
Add them.
Michaela?
Subtract.
Michaela? What have we been doing with scale factor?
Multiply by.
Multiply. So 7.1 times 40
Equals 280.
cubed.
82.6. Oh, you found that. 422,060 inches.
Yeah, whatever that is. Yeah, you can figure this out on your
I
own.
only got 22 million. That's right on the.
Oh, wow.
Get it.
I don't either, Alex. I don't understand.
How could you with all the chaos? Huh? But it's on video, so you can look back and listen to your classmates.
Screech and holler.
It's a good word for it.
Weird.